Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking Pivotal for sponsoring today's event. Pivotal is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Tableau, Microsoft, Hortonworks, Oracle, IBM, and Teradata, to name just a few. These past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of current interest to our data science community. Today's webinar is entitled, The Past, Present, and Future of Data Science, a Live Roundtable. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be about 1 hour long. We have 3 panelists that I'll introduce in just a minute. Today's event is open format, live discussion, roundtable. And this event is being recorded and will be available on datasciencecentral.com in the next few days following today's live event. So as this event is different from our standard educational webinars, I'd also like to encourage our attendees to provide questions throughout today's live discussion. This is a unique opportunity for those attending today's event to participate fully and engage directly with our esteemed panel. So I'm very pleased to introduce today's speakers, Sarah Erni, Wu Zheng, and Rashmi Raghu with Pivotal. Sarah is a principal data scientist at Pivotal, leading the San Francisco practice. She executes projects with customers from pharmaceutical companies and healthcare providers to financial institutions. Before Pivotal, Sarah obtained her PhD from Stanford in biomedical informatics, performing research at the interface of biomedicine and machine learning. She also co-founded a company offering expert services in informatics to both academia and industry. Wu is also a principal data scientist at Pivotal, with a background in industrial applications of both humble and advanced inferential statistics. He's focused on delivering a wide range of data science projects. He's also passionate about the adoption of R and other advanced analytic tools in the big and fast data ecosystem. Prior to Pivotal, he was a senior statistician at a Bay Area startup, mFactor, now part of IBM, where he built and delivered demand analysis solutions powered by Bayesian hierarchical models. He holds a Master of Science in Statistics from Stanford and a Bachelor of Science from Cornell. Rashmi is a principal data scientist at Pivotal as well, with a focus on the Internet of Things and applications in the energy sector. Her work has spanned diverse industry problems, including uncovering patterns and anomalies in massive data sets to predictive maintenance. She holds a PhD in mechanical engineering with a minor in management science and engineering from Stanford. Her doctoral work focused on the development of novel computational models of the cardiovascular system to aid in disease research. And prior to that, she obtained a master's and bachelor's degree in engineering science from the University of Auckland, New Zealand. Well, thanks for being with us today. I'm looking forward to moderating today's discussion. So as I mentioned a moment ago, today's Data Science Central webinar will be a live roundtable discussion with the introduced members of the Pivotal Data Science team. This is a truly unique event that is intended to provide DSC community members a full hour to interact with and learn from their years of real-world experience. You, the audience, are again encouraged to participate and take advantage of this unique access and knowledge base provided here today. So be sure and enter your questions right away in the QA box on your screen. So today's discussion will focus around some of these questions, not limited to these, but we're going to try and cover at least how did you become a data scientist? What steps did you take? What are the most important qualities of a data scientist? How would you describe a typical workday? What's the largest data set you've worked on? What tools or platforms do you use? R, Python, Hadoop, or so forth? How do you think the field of data science will evolve in the years to come? What tools and techniques are you looking forward to using in the future? And in what ways do you think data science will continue to transform these industries? And once again, these are just our suggested questions. So audience, please be sure and send in the questions that you're interested in discussing with this interesting panel. So let's get started. We're going to start with some get-to-know-you questions. And let's start with just a discussion of, well, how did you become a data scientist? And I'd be interested to know also if there was a particular aha moment when you knew that data science was going to be your future career. So let's start with Sarah.
Great. Thanks so much for the introduction. So I don't think there was an aha moment for when I wanted to become a data scientist. I think there was an aha moment for when I realized what I was doing was data science in reality. And I would probably assume that that's the case for many people in this field by now. I often joke that the way that I got into data science was with tennis, because when I was in high school, I had to take a class in computer science. It was the only one that was offered for an elective at the time that didn't interfere with my other tennis-related activities. And that was my first chance to kind of touch upon that field in general. But I was always passionate about biology, and in college I was able to, in my first year, enter a new major that just came into existence, bioinformatics. And that in essence is the concept of taking machines and discovering patterns inside of the biological domain. So I really started off focusing on genomics space, meaning looking at DNA and mutations in cancer, and then moved forward into grad school to actually work on image-based analyses, so looking at images and trying to understand what it was that we were looking at and using computers to kind of solve for what it is that you might be doing by hand. So in essence, what that becomes is building models for biologists. And then, of course, I started a consulting company that was meant to bring the concept of informatics to all other groups of biomedicine, and then extended beyond that ultimately into things like looking at weblogs to try and predict what somebody might be interested in looking at, even did a foray into a dating app for matchmaking services. And again, in all of these instances, it was this concept of taking data and trying to find something that was predictive. And really that's when I would say I realized that this concept of data science, which at the time was just coming to be something kind of big, was actually what I was working on. When I started grad school, there was definitely a lot of talk about this wave of bioinformatics that was coming, and that they needed to train people up for the wave of bioinformatics, and I was sort of entering at the beginning of it. And of course, when I left grad school in 2012, it was then the wave of data science that I'm entering at the beginning of it. And I think these waves ultimately are this concept of applying machine learning and stats to sciences, and it was really earlier very specific, and we wanted to name each subdomain. And I think now we've moved into the space of allowing that concept of analyzing large data sets to really be generalized to something like data science. So that would be really where I would think it came from for me. But I'd love to hear, Wu, what your perspective is on how you arrived here.
Sure, thanks, Sarah. So I would have to say that I kind of fell into this in one way or another as well. I think I actually still remember my first statistics course that I took in college, and it was new for me because I think at the time, like, I was thinking about ways to, I guess, gather evidence to support a hypothesis or to support a, let's say, an argument. And it's great to get qualitative evidence to support your claims and to make a point. But I think what was very interesting about data analysis, data science, statistics was that it was an opportunity to use data as evidence to test the hypothesis, right? And so that was very, very interesting to me, and it just made a lot of sense, right? In terms of, you know, what's the best way you can actually present a specific point or a specific point of view, and have it be as objective as you could make it, right? And so, yeah, that really kind of got me down the path of statistics. And I think, like, in that second semester of that course, we started to touch on, like, regression analysis. And that was really interesting because I actually didn't know, like, anything like that, where basically you have, like, this outcome of interest that you wanted to learn more about. But it wasn't about, like, writing prose or a bunch of, text and qualitative, words about, why this point of view is true or why this hypothesis is true, or even like beyond, laboratory test results or things like that. But it's actually looking at data and then putting it into a real model, right? That basically, relates a bunch of input variables, input factors on an outcome of interest. And not only are you able to predict that outcome to a reasonable degree, assuming you have good data, but you're also able to explain, why that outcome is the way it is because of these factors that you've included in this model. And so that was very interesting, and I saw that as something potentially very powerful, and I wanted to learn more about this thing. And so I guess that kind of got me into, getting more interested in this field in general. Applied for a master's program in statistics and really enjoyed that program. And then I guess for me, more than kind of the theory and the math and sort of the underlying, I guess, proofs and theorems that kind of go beyond these statistical algorithms that we use in data science, I think it was more about the applied portion that really got me interested, and the ability to actually, or the opportunities that we have to actually test out these hypotheses with real data. And so that got me interested in sort of more industry positions more than academia. And yeah, I mean, I guess did some of that at my first startup at mFactor, and then continued doing that here at Greenplum and Pivotal.
So Rashmi, on to you.
Great, thanks. Thanks for the introduction, and Sarah and Wu definitely have very interesting stories. And just like that, I guess I have a little bit of a windy road. It's not necessarily the straight path into, well, one might think, data science is what I want to do. Of course, when both all three of us, Sarah, Wu, and I, were doing our undergraduate degrees, I don't think there was anything labeled data science at the time, or any programs coming around in that way. But what I did was I ended up being very interested in applied problems of engineering. So I ended up taking a major in my undergraduate degree, which brought together advanced mathematics, technology, and computing to solve real-world business and industrial problems. And so that really formed the foundation of what even we're doing now. It was very much an applied sense, very much applying all of the hard technical things to real world problems. And coming out of that, I had a choice of focusing on various different fields, and I ended up focusing on the biomedical or biomechanical side, which is what led me to a PhD in mechanical engineering. So you wouldn't many people might not necessarily associate mechanical engineering with the current field of data science, but for me, it was a very logical progression in my career and my studies, and it was very fascinating to see that a lot of the mathematical underpinnings, hold. If you have the underlying rigorous principle set, then you can apply it in many different spaces, be it biomechanics or be it machine learning. So from moving got me interested in the application of mechanical principles and mathematical principles to disease research, which is what I did in my PhD, cardiovascular disease research. And because our bodies are essentially mechanical in nature as well as chemical and biological in nature. So moving on from that, towards the end of it, during my PhD, I also kept in touch with the industrial engineering side by doing courses in a minor in management science and engineering, and moving from that, it seemed a very logical step. As I was finishing my PhD, this new emerging sort of coalesced field of data science was coming into the view, and it was very much a very logical step for me to come and work in this field because a lot of the background that I had came together kind of very nicely.
Rashmi, thanks very much for that insight. And you know, I share with Wu my own personal aha moment was, I think, the first time I was exposed to regression and suddenly realized that, boy, a little bit of math and a little bit of code, and I could actually predict the outcome of future events. And to me, that was very exciting, too. You know, we have lots of questions coming in from the audience, and I'd like to encourage the audience to continue to submit those. We're going to try to get to all of them. Let's do one more round of introductory questions. And, you know, ever since that Fortune article came out that said data science was the sexiest career of the decade, obviously everybody wants to be a data scientist, but let me ask you all, what do you think are the most important qualities of a data scientist? And Wu, maybe this time we'll start with you.
Sure. I think, I guess speaking from our, the Pivotal Data Science team's experience when we're looking for candidates for hire, I guess at the core, we're looking for folks who can, write code, and we're also looking for folks who, have an understanding of machine learning and statistics to some degree. And then thirdly, we also look for great communicators, someone who could take these, very complicated, sophisticated mathematical models and be able to explain and present, the results to a non-technical audience. So, to recap again, so code, statistics and machine learning and communication skills are sort of the three main things that we look for. But I think Sarah has a few things that she'd want to add to that as well.
I actually just have one thing that it's not necessarily something that can be taught or gained, but it's a question that I think every data scientist probably asks him or herself, which is, am I passionate about data? I think with Rashmi and Wu, it really came through this concept of how amazing, and Bill as well, how amazing it is to take data and allow data to answer questions and allow data to actually speak and provide you with information, not necessarily coming from the perspective of I know something and I want to see it, but can it serve that up? And there is this, on our team, prevalence of a curiosity where you just need to know and need to ask as many questions as possible about that data. We are very sticky with it, spend a lot of time with it, and what might seem boring to other people that are maybe not in that space of data science, to look at it, to plot it, to ask a lot of questions, use stats to see whether or not there is a real signal. The excitement that comes out of that is definitely something that is really easy to spot and know within yourself that this is great and exciting. So, Bill, hopefully that answered the question.
Yep, very well, very well. Thank you very much. So the viewing audience has started right in with some very pointed questions, and the very first one they would like you to comment on is a big one in our field, and that is, well, what's the best language for data science, R or Python, or something else?
Sure, I can kick things off, but I think this is, at the end of the day, it's mostly about personal preference and what the individual is most comfortable coding in. Because I really, to be very honest, I think for me, like, coding is just a means to an end, and the end for me is actually to study this data and to build some good models that are representative of that data. And so really, I mean, it's just like whatever gets you, the most, whatever gets you moving the most quickly and most efficiently with data, I think is probably the right answer, and that's going to differ from individual to individual. I guess very personally, I mean, this is not something to generalize for all data scientists, but for myself, I mean, I picked up R it was probably the first programming language that I really kind of got into, and that was like back in college, and so it just kind of, it feels more natural to me to use that language more than others, especially during my time here at Pivotal. I've also become very, very comfortable with SQL, and so that's also been super helpful, especially in data preparation and data cleansing, but also not only that, but also for statistical and machine learning modeling as well. So yeah, I mean, I don't know that there's a ton of objective value in like saying, oh, this language is better than the other, but then for me, I think my opinion would be that it's really whatever you're most comfortable with, and at the same time has enough kind of built-in libraries that you don't have to be coding everything from scratch and wasting your time that way. Yeah.
I definitely feel like with the R and Python question, which was mentioned, it's like starting a war. It's the VI versus Emacs question, or whatever your flavor of argument is that exists. And I just from my perspective, I actually came in from the first language I learned in that space was Python. Before that, of course, I had exposure to things like C++ and Java, and exactly what Wu was saying. It's all about being agile enough to be able to say, okay, there's a library that I need, and I'll be able to get my hands dirty and get in. So that's definitely something that needs to be considered.
Yeah, this is Rashmi. I'll add one thing, which I guess, unlike either Sarah or Wu, I was not a heavy user of either for until more recent years, and I basically came from the MATLAB world. If anyone out there, I'm sure many of you know what that is, and so I have sort of an equal exposure to both in terms of R and Python, and I know there's advantages to both. Again, like Wu and Sarah said, Wu said that it really does boil down to personal preference in the end. So I think they're equally sort of very much advanced in many ways, and I can say that as having somewhat equal exposure to both.
Well, thanks. Those were all very tactful responses. So, audience's question. How much do you get involved in software development at Pivotal besides doing data science consulting with clients?
Yeah, I can take that one. I can kick that off. It basically, I think, boils down to how, in a lot of ways, both preference and how much consulting work is in the pipeline as well. So oftentimes, we have a lot of consulting work in the pipeline, and so we do things more in that realm. But also when there's a lot of wait time or downtime, then we get involved in helping with the toolkits like MADlib, if you're aware of what that is, the database machine learning library, helping build that out or helping test that out and things like that. So we definitely are encouraged to do that in terms of software development at Pivotal. Especially also evaluating, new tools and things like that is also a part and parcel of what we try to do, building out demos, using the new tools or new libraries, and in the very fast evolving space of data science and big data technology. So we're definitely encouraged to do that. Exactly how much time on a day-to-day or month-by-month basis is hard to predict, because we do have the variation in schedules coming from a pipeline of consulting work. Wu and Sarah, anything to add?
Yeah, I mean, I guess just a quick add on there. I agree with everything that Rashmi has said. We're actually part of an organization at Pivotal called Pivotal Labs, which has, software developers, application designers and product managers. And so, more and more we're actually working sort of cross-functionally with that broader team to build smart apps or data-driven apps for our customers. And so I think that's something unique that our team is doing in terms of, what's available out there. But it's going to be, it's always exciting to work on those projects, and I think it's going to become even more central to our team's focus in 2016 and moving forward.
Terrific, thanks. So next question from the audience, and this one's also interesting to me personally. How is inferential statistics used, especially in big data analysis?
Sure. Yeah, I can kick things off here. So I think like inferential statistics is basically the process of, I guess, deducing things about like your population's, let's say, distribution or your population mean using a sample of data, right? It's basically mathematical generalization, right? That's what statistical inference is. And I think with big data, it gives you an even more accurate picture of that broader distribution that you're trying to estimate. And so the more data that you have, the more data points that you have, the more accurately you can approximate that distribution that you're aiming for. And so more than anything else, I think going from small data to big data, it gives you kind of just much more ammunition to make your inferences more precise, and also it gives you the opportunity to test more hypotheses accurately because you have that many more data points to sort of back yourself up with. And so I'll say it again. I mean, I think with big data, it gets even more exciting because you can build more intricate models. You could study more. I guess kind of more precise effects, and also use this data if you have sort of the right platform to be able to analyze it in ways that you wouldn't be able to do if you had a much smaller data set. So I think, yeah, at the end of the day, more data makes things much more interesting for data scientists.
Woo, thanks. Anybody else care to weigh in on that? Great, thanks. We'll move on to the next one. Oh, sorry. Go ahead, Sarah.
Oh, no, I think Wu well covered it. Thanks.
Okay, great. Here's a very interesting question, and it has to do with whether or not you think recent MOOC courses and certificates in data science, big data, and machine learning provide the real skills needed by data scientists. And I'd like to expand that a little bit. Everybody on our panel here is very highly educated, either a PhD holder or a master's degree. Is that necessary to become a data scientist today? Or will these MOOC courses and relatively quick access to data science education do, at least for entry level?
I'll take that at least initially. So absolutely, our group, our team in general is highly educated, although we often get the question, is a PhD required? And it is, of course, not. Our team is not all PhDs, not even half. However, we have now been slowly exposed as well to people who have gone through these online courses. And they certainly teach a lot of good fundamentals that allow, I think, the person on the other end who's receiving the education to learn if they find it exciting. I think, again, data science is a space that you go to. It's not kind of a job that you'll just go and execute every day. You really do need to find excitement and passion in it to do well at it. So these courses give you those opportunities. And I think for those on the team that actually have gone through these courses, many of them came in with a strong foundation, generally in something mathematical or computational that they were able to build upon once they show up to these courses. The courses give a good overview, and it's really about getting to the point where you're able to put that into practice and you're able to see in reality, what does it mean? What are the actual effects kind of in the wild when you work on the data set of having, for example, an outlier, which is something these courses teach you a lot of the lingo and a lot of the things that come down to being rules of steps that you feel you have to go through. But it's not enough, I think, in data science to just go through the motion. It is about actually understanding why there might be a problem and then discovering that the data proves sort of that the things that you've been taught are reality. And so I think that's good motivation for getting started, and then either in a job or in some more courses to go through next steps. But Rashmi, you might have more to add to that as well.
Yeah, just adding to what Sarah said, the MOOCs and the online courses definitely give a broad foundation and broad exposure, especially to the lingo if you're not familiar with that, and to basically hooks to find out what it is that you know and what you don't know, and so you can dig in further into those that might be a little bit less familiar to folks, to those taking the courses. It does help if there are certain technical aspects that are not familiar to deep dive into some of those. Maybe if there is like some type of mathematical procedure or calculus or what have you that is not familiar to folks, then maybe that's something that you can deep dive into once exposed to the broad foundation in these MOOCs. It's well worth diving, I think, into some of these more behind the scenes, what is going on. And the other one I will add is in a lot of ways practice makes perfect. So if you go through these processes within the frame of feedback, say if you're part of a community, if you can become part of a community beyond the going through the MOOCs, part of a community which will help you where you can work on data sets, work on new problems, different problems, look at the same data set different ways, and gather the feedback from a supportive community of data scientists or what have you, then that really adds to the learning experience. And as Sarah said, I agree that there's a lot of curiosity and passion that people will realize with the MOOCs, whether they like the procedures or like the aspect of going through that, because you never really, the data set isn't the same all the time, the problems aren't the same, so it requires fresh thinking almost regularly. So that's definitely something that you get a flavor for in the MOOCs. But I would say that try and expand beyond that and be more innovative and being more innovative in learning and getting exposure and practicing those skills will really help.
Well, Rashmi, thanks. And, we talked about kind of the long version, that is getting an advanced degree, and the short version using MOOCs or short-term classes. But there's also an explosion in even bachelor-level programs today as well. And that leads us to our next audience question, and that is really, what do you suggest for folks seeking entry-level positions in data science? Where would you go to look for a job? What sort of credentials would you put forward? How would you prepare yourself?
I can start that one off, and again, I'm sure everyone has a lot to add to that. If we're talking about resume preparation, I would say that probably the number one thing to focus on is, first of all, your background in something computational, some sort of a programming language, make sure that that's highlighted. And then on the other end, for at least at Pivotal, what we focus on, again, either stats or machine learning as a foundation, but really nothing too deep at an entry level. We don't expect you to have a lot of experience. And I must say that even the concept of data science, which we didn't do up front, varies from company to company. You'll go to one company, it's really, data science can encompass BI, or maybe it's, A/B testing. For us, it's very specific around predictive modeling. And so somebody starting out, if you're at an undergrad, make sure that you take those computer science courses. Make sure that you take, at least stats, understanding that machine learning isn't offered at every single university. And the online courses may be useful, but it's really that strong foundation. And then the ability to understand why these things matter. So not that you have to throw equations up on the board, but really to understand the underlying question that you're asking so that you might be able to apply it somewhere. I don't know if someone else has to add to that.
Sure.
Yeah, I can add a little bit. Go ahead, Wu.
Oh, no, go for it, Rashmi.
And so I can add to that in the sense that, as Sarah said, entry-level requirements are, not the PhD style or anything like that, but good level of foundation and basic understanding of why something is used where, even if it's just the simple models or the simple things. And knowing something well is sort of better than knowing a lot of things very in a little too shallow sense. If I'm being clear, is that knowing sort of the nuances of even the simplest algorithms or the simplest models or the simplest applications of those is actually very useful to have, very useful to see. And that means that when people are exposed to more complicated things, as either as part of a job or as further study, whichever it happens to be, then they get to see the different aspects of a problem or different aspects of a modeling methodology and where it could be applied and when it's appropriate, when it's not appropriate to be applied. So that's just my 2 cents.
Yeah,
Thanks.
Just
Go ahead,
one more from my end, I guess. If you're out there just getting started in data science, then I think one other question that could be good to ask is, do you want to work on a wide variety of problems and get exposure to that wide variety of problems, or do you really want to zero in and focus on a single use case and go really deep into it, like clickstream analysis or ad optimization or something like that, right? And so I think it goes down to personal preference, and so from the perspective of the job applicant, I think that's also some a factor worth considering when you're applying for jobs in this field.
Yeah, I completely agree. Probably as recently as 5 years ago, data science was considered a very general pursuit, but these days it's very easy to specialize and deep dive in some particular portion of our practice and become a real expert in a fairly narrow but high value area. So, relative to high value, the audience would like to hear. So what type of business cases are you helping to solve? Are they general or specific, and would you provide some examples?
I can kick that off. Actually, they do tend to be specific in the sense that even the same use case across different verticals or across different companies can have very nuanced and very specific issues associated with it. One specific example I'll give that we quite often work with these days is predictive maintenance, which is, taking data from equipment or machines and how they're functioning and to be able to say when or whether they might fail in the near future, which helps both manufacturing companies that use the equipment, maintain them, repair them, proactively deal with any issues ahead of time, and so on. But you can imagine, in a general statement of the question is predictive maintenance, but the very specific in different industries will vary quite widely. Whether it's oil and gas and drilling predictive maintenance, or utilities with predictive maintenance of their equipment, or various or any other manufacturing and heavy equipment industry. So the equipment will be different, the sensors placed on it will be different, the rate at which data is coming in will be different, the way in which faults are captured and recorded will be different. So all of those specifics, even if you're as we were just talking about, deep diving into specific niche areas, you could spend a lot of time in predictive maintenance and still have a variety of problems that you deal with. That said, there are some which have been very that have been done very frequently in other areas like churn modeling or customer churn prediction. Again, the data sources might vary, but the methodologies might be a lot more understood and a lot more straightforward. So there's a whole bunch of use cases like that. And in any case, any use case that we deal with predictive maintenance with its variety and novelty, because a lot of those things are still new, with sensors being deployed and so on and so forth every day. So with all these things, we always learn something, even if you're doing the same thing like churn modeling, which has been done a lot before, or with newer data science fields like the Internet of Things and predictive maintenance type things. Wu, Sarah, anything to add?
Sure. Yeah, I mean, I think Rashmi's mentioned a couple of use cases that our team frequently encounters with customers. So yeah, predictive maintenance, churn modeling. I guess I can speak to another one. Actually, this one was interesting because it was with a major manufacturing company that we had engaged with, and along with doing a lot of quality control type of predictive analytics on their manufacturing factory data. Something very interesting that we were able to do was actually generate a lot of visualizations, like thousands and thousands of visualizations that would be piped to technical analysts. And then these are visualizations of particular graphs or specific metrics that would inform them whether or not there is a quality control issue on their factory line. And to some people that might sound like pretty basic stuff, like it's just a bunch of graphs that you're producing. But even at that level, although we were also building sort of these machine learning models in tandem with these graphs, if you're able to reduce the number of hours that an analyst, or the number of images that an analyst needs to take a look at, from potentially millions to just maybe a few hundred, I think that's a huge additional value that I think data science and analytics is able to provide for that specific workflow, right? And so I think the ability to produce lots of visualizations and be able to sort those visualizations in a way that reduces the amount of human effort that's required to solve out a particular business problem, I think that's another area that we like to focus our team's attention on as well.
Wu, thank you very much for that, and Rashmi, thanks for those answers. And so now our audience is getting more specific. And based on your client delivery experience, do you have a favorite statistical or machine learning technique?
I definitely don't want to say that I have a favorite. They're all context dependent. I think from a customer perspective, because I think the question was around client delivery, we always have to consider that trade-off of interpretability versus accuracy. And sometimes it's a bit of hand-holding that gets you to be able to say, well, if we allow these more complex concepts to be introduced versus just a linear combination of terms. I remember going to a financial services company where they were used to building risk models, and to them, they would say, oh, I don't understand this concept. I'm used to multiplying things together. It's really at that level sometimes that you struggle with a very specific feeling. As far as kind of favorite machine learning techniques or stats methods, I can tell you, though, that in the space, what comes up constantly as a question right now is deep learning. Everybody is talking about deep learning and wants to apply it and thinks that that's the next big thing. And I would say also those online courses that were mentioned earlier teach them. And so it's something to keep in mind. I would say that a lot of us, and we will probably murder me for saying this later, but there are some go-tos that everybody tries. Everybody goes after baseline all the time. I would say either, of course, is a classification or regression, but you might go after a logistic regression and then throw it out a random forest or boosting, because you want to be able to say, are there more complex, maybe subpopulations that could be represented by, interaction terms that could be captured in a more automatic method. I know when I graduated from grad school, everybody was talking about SVMs, and I feel like, with the deep learning now, neural nets is probably revived in that sense. But I guess I didn't answer, but sort of the perspective of the world, maybe.
Right.
Wu, do you have something to add?
Sure. Yeah, I can go next. I'd have to say, in terms of what we use most with our customer projects, it boils down to typically a regression or a classification problem that we're tackling. Sometimes we also do a lot of unsupervised learning, like clustering type of analyses for our customers as well. But I guess in terms of just what's most inherently interesting to me, just purely from an algorithmic perspective, I would have to go with either the Bayesian methods or anything really that simulates its own distribution. So it could also be something like a bootstrap type of approach. But yeah, if we just focus on the Bayesian class, I guess, of algorithms, it's super interesting because I like the fact that, especially for hierarchical Bayesian models, it uses the structure of the data as data to inform the models. And so what I mean by that, another way to say that is it uses metadata as data to build your models, right? It becomes, along with the data points, it also uses metadata to estimate like regression coefficients, right? So an example would be like, if you're building a model for the United States and you have data by U.S. state that you have collected, and let's say you want to build a separate set of coefficients or effects for each state. There's this concept of, I guess, shrinkage where basically, they're all independent states, but then they're also part of this family of states called the United States. And so wouldn't it make sense to think that, although California and Oregon are separate states, wouldn't you think that they would share some inherent similarities? And because of that, wouldn't you want to leverage that knowledge and use that as data points to inform the final estimates that you're putting together for these states? And I think the Bayesian framework gives you a nice way to incorporate that sort of like metadata or structure of the data into the analysis, and I think that's just really, really interesting, just from a pure, I guess, statistical or machine learning perspective. Yeah.
Right. Well, Wu, thank you very much for that answer.
And I think actually Rashmi also had,
Sure.
think, a couple of things to add there.
Yeah. Oh no. I think Wu and Sarah did cover it really well. I think from a client delivery perspective, it really just depends on the project that's coming in, and we oftentimes also use unsupervised learning techniques, and a lot of times there have been use of graphical approaches as well. But in many cases, it simply boils down to that the use case requires a lot of data preparation and cleansing and nuances of that end, and the modeling itself might not need to be super sophisticated, because the question is one of getting the pipeline for data science as much as applying some very sophisticated machine learning technique. That said, there are situations, of course, where deep learning and Bayesian models and things have been applied or are of interest in many situations. But at the same time, there are an equal number of situations where you may just be able to very satisfactorily apply something like ElasticNet for either classification or regression and things like that. So as well as basic clustering techniques like k-means clustering or hierarchical clustering, and get very satisfactory, very applicable, actionable results from those as well.
Right. Well, thank you very much, all of you, for those great answers. So here's a question that appears to come from one of our social science brethren. And since all of you have technical backgrounds, the question is, did you ever get involved in social science projects, and how did you bridge the gap between the two areas?
Yeah, so that's an interesting question. Actually, at Pivotal, we have a program called Pivotal for Good, which allows us, those of us who've been more senior members of the data science team, have been here for, I think the tenure is 3 years and up, to be able to take 3 months of our time and actually spend it with a nonprofit doing data science work for them. And we've, so far, one of our colleagues has executed one such project, I believe, with helping at-risk youth in a nonprofit called Crisis Text Line. And that went over really, really well, because they really appreciated the use of her data science time. Noelle Seal is our colleague's name, and she did a great job there. And all of us, I think, who are in this webinar now, we're all eligible to go do that, and we're all in line to be able to go donate our time to a relevant nonprofit and be able to spend to be able to take our technical skills and use it in a very proactive and very nice way for helping other folks that might not be able to afford data consulting services like this. Wu, Sarah, do you have anything to add?
Yeah,
no,
sure.
Sorry.
Yeah, just a quick thing there. I mean, I think yeah, definitely the Pivotal for Good projects have a lot of social science aspects as well. Especially a lot of the projects that we're considering, including the one that Rashmi mentioned that Noel executed for the text line. But I think in a lot of our projects, we're using a lot of tactics that I guess social scientists typically use in data analysis, problems. Things like leveraging census data, government data, Bureau of Labor Statistics data into the analysis. A lot of economists, sociologists are doing a lot of that, or have been doing a lot of that over the years. And so in some sense, there's a social science aspect in all of our projects that we're executing on. But yeah, I mean, we have a couple of folks also in our team who have a background in social science, like a couple of folks with degrees in economics, for instance. And so, yeah, I mean, I think it becomes sort of a gray line, like data science, statistics, machine learning, social science, quantitative social science. But I think I can definitely say that we are, for sure, applying a lot of the tactics that social scientists typically apply in their problems as well.
Okay, well, thank you. In this era when data science is so exciting, the audience is asking, are you fans? That is, which data scientists or startups do you admire the most?
I guess I can kick this one off. I don't want to necessarily call out any single data scientist, although I'm sure all of our favorite person that we follow. There's certainly someone that I've followed from company to company to kind of see where she's gone, and then I tend to watch those companies, I have to say. And there's sort of, I think, a lot of the obvious companies that people talk about where I think the comment is like very commonly Uber. It is a phone app. Of course, they have grown up in the world of big data. And for them, it's easy. And of course, much respect to the work that they do. It is fantastic work. But to me, I think what I admire most are companies that undergo transformations. They start off as big companies, and they're able to figure out how to maybe Uberize parts of their companies. So I would say what's interesting for me particularly is to look at a company like, I would say, GE. And I'm sure, Rashmi has a lot of experience with companies like this that have a lot of sensor data, but to see the way that they are so willing to start off being very scrappy with parts of their business and figure out how to introduce data. And then what I've seen across all of their different organizations, the way that they are taking the data that they have, putting it as the center and finding ways to grow new products out of it, finding ways to improve their current operations, finding ways to improve their current offerings. I find that amazing. To see that sort of growth.
Yeah, similar to what Sarah said, I think it's hard to pick out companies because we obviously work with many of them, and but there are so many that are now really starting to see the fruits and see in a more concrete way envision the power that data could bring to them, what they could do with it, and not just have it be hype. So I think the fact that it's going from inception to productionalization and operationalization, I think is where are the organizations and the people who drive that are what we sort of admire more.
Oh, well, thank you for those answers. As we come up here on the top of the hour, I'd like to offer you one last question, and I think you'll enjoy this one. That is, in what ways do you think that data science will continue to transform industries?
Sure. Yeah, I can start with that one. I think we briefly alluded to the fact that more and more here at Pivotal, and specifically within the Pivotal Labs organization, we're seeing opportunities to build data-driven apps or smart apps for our customers. And to quickly kind of define that one more time, literally, a particular, end-user facing app that's being developed by software developers and application designers and product managers, but kind of in sort of the background is sort of this data science model that is giving, sort of acting as the brain of that app. And so you can think of examples like, particular recommendation engines that would have a UI component also built as a part of sort of the final product. Also early warning systems where we look for anomalous signals, and that would sort of be the work of sort of the data science models or the brains behind the app, and also tied together with a very well-defined, very well-designed interface that actually makes these analytics stick and useful for end users. So I would say it's really all about the smart apps and the data-driven apps, and I think there's a huge opportunity there for folks to get excited about.
Wu, I love the perspective that you're giving kind of on how it all comes together. I think that's such a vision that we have here at Pivotal. So certainly I think that definitely feeds to that future. I think I'll take a slightly different angle on this question, which is something I think that it was introduced to me some time ago, actually, this concept of kind of not only what the future of data science is and how it's going to drive businesses, but I think also how it's going to drive us as a society. It's something that I think about a lot, actually, and probably isn't totally on topic of the question, but I think it's something that we as data scientists need to consider in everything that we're doing, kind of this bit around social responsibility, also responsibilities to our customers to allow them to understand that I think everything going forward needs to consider not only how do we succeed at our task at hand, but how do we succeed at actually doing what's right, not just in the short term. So, of course, we can think about, I think an easy example is how to get people to interact as much as possible with my application, to make it sticky, keep people there. And there's the one side of the coin, which is I succeed in the short term at getting someone interacting and touching my app constantly. But at what point does that backfire potentially? At what point does it become, I'm spending too much time with this, I need to back away? And at what point is it also kind of our duty to make sure that people back away when needed and to not get them overly indulged in an application? Because at the end of the day, what we need to do is make people's lives easier to get them back to doing what they love and care about. And so remembering that as well. So I think the future of data science also involves some amount of that social responsibility.
Yeah, I'll round it off by saying I agree with both Wu and Sarah. I think the future of data science is going not just from individual algorithms, not just focusing on individual algorithms, methods, or use cases, but seeing them through from inception, right from inception, looking at what the end goal is and what the application of it might be, and having people use it in a meaningful way. And again, as part of that, I think we'll see more and more of what Sarah said, which is this notion of when is it too much, and when is it that we may need to maybe use the power of data science again to make sure we have the optimal interaction, not just a lot of it all the time. But yeah, I think in many situations, especially where in situations where you're trying to prevent disasters or help people that are in need, then I think a lot of this could have a lot of potential. The future of data science, going from the end-to-end inception to application, I think is where we will see a lot of potential and a lot of both potential and responsibility for us.
Well, Sarah, Wu, Rashmi, thank you so much for your enthusiasm and your candor and your professionalism in addressing and sharing so many wonderful real-world experiences with our DSC members today. For those of you who've asked questions that weren't answered today, we'll be sending all those unanswered questions to the Pivotal team so they can follow up with you after today's webinar. Now, I have just a few quick announcements. If you'd please mark your calendars for January 26th, that's our next DSC webinar, which will be Applying Graphic Design Principles to Create Killer Dashboards, and that'll be sponsored by Tableau. Also, remember, today's taping will be available for on-demand viewing later today, and you can find it on the homepage of datasciencecentral.com in the Webinar tab located at the top of the page. So this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Pivotal for their sponsorship for this very special and interactive event, and our panelists today, Sarah Ernie, Wu Zheng, and Rashmi Raghu, for their participation in today's live unscripted event and interactive as well. Well, my name is Bill Voorhees. I'm very pleased to have been your moderator for today's event. I look forward to seeing you all again on January 26th. Have a great day.